We're going to look at a cost problem. What is the energy cost of running an air conditioner for 24 hours a day for the months of June, July, and August if it uses 120 volts at a current intensity of 100 amps and the hydro rate is 8 cents per kilowatt hour? So the first thing we're going to do is we're going to write down our givens. When looking at an energy cost problem, it's the only time that we have to have energy in kilowatts and not watts. Okay? Our electrical power is measured in watts, but we are charged, in terms of the energy we use, we are charged by the kilowatt hour. So that all comes back to this formula. E is going to be equal to PE delta T, right? So PE is measured in kilowatts, and T is going to be measured in hours. That is where our kilowatt hours come from, all right? Now, first thing we've got to do when we see a problem like this is we've got to figure out our time. And we can do that based on the information we were given. We were told that the air conditioner is going to run 24 hours a day. And we're told that it's going to run for the months of June, July, and August. So if that's the case, you need to know how many days are in each month. In June, we have 30 days. In July, we have 31. And in August, we have 31. So we have to take the sum of these days. If we look at all the days, what is our day total? 92. This makes up 92 days. So what we're saying here is that the air conditioner is going to be on for 92 days at 24 hours a day. So the way we want to look at this is if we've got 92 days, okay, in one day, how many hours? 24 hours. Days cancel out. Multiply 92 by 24. Good luck. So that gives us 2,208 hours. Now, we've got the hours down pat now. Now we've got to look at solving our electrical power, our PE. We got to get the kilowatts. Okay, so if I look at what I've got, I'm going to use the formula. I see here that I've got my volts and my amps. So I've got my V and my I. And I look at my formula sheet and I see that PE is equal to potential difference times current intensity. So if I look at this, I've got 120 volts multiplied by 100 amps, which should give me 12,000 watts. But we can't leave the power at watts, because what does Hydro-Quebec charge us in? Kilowatts. And there are 1,000 watts in a kilowatt. So we then look at converting this to kilowatts. So if I've got 12,000 watts and I want 1 kilowatt here, how many watts are in a kilowatt? 1,000. Okay, so these watts cancel out. So you're going to just divide 12,000 by 1,000, which should give you 12 kilowatts. Now, do we have our hours and our kilowatts? Yeah. Yes, we do. Look, we figured out our hours up here, 24 hours a day for 92 days, and we figured out how much kilowatts or how many kilowatts we actually use. Now we can get our energy. Okay? So our energy, we go back to that formula way at the top. Energy is equal to the electrical power times the time, right? What is our electrical power? We just figured it out, 12 watts, kilowatts, sorry. And what is our time? 2,208 hours. So if we multiply these two, we will get a number in kilowatt hours. What is the number? So that gives us 26,496 kilowatt hours. Kilowatts from the electrical power and hours from the time. Okay? Kilowatt hours. Now, I'm not done. Because what I've got to do is I've got to go back to my cost calculation, which is the cost is equal to the energy times the rate that I'm being charged. And if I look at this, I have my energy, which is 26,496 kilowatt hours times $0.08 per kilowatt hour. And if I do that, these little kilowatt hours are done, they cancel out, and I'm left with dollar signs, which is what cost is represented in. So if we actually multiply this out, we end up with an amount of $2,119.68. That's how much it would cost us to run that air conditioner 24 hours a day for the months of June, July, and August. Okay?